So thank you all these startups for the joining us for the Hedera Workshop. Hedera is the FIS global partner and the most used enterprise-grade public network for you to make your digital world exactly as it should be, yours. In this session, you'll get an introduction to the development on Hedera, including an overview of the core concepts and the use cases that will ensure your next Web3 project is a big success. Let me introduce you to the current speakers for this workshop. Matt Woodland. Matt heads the developer relationship at Swid Labs. He's an experienced full stack developer by trade. He loves all the software things, technology and innovation. He's a deep passion for Web3 and NFT projects, empowering developers through learning opportunities and leading with empathy. We also have Francisco Kochi, who is a developer evangelist at Swid Lab, passionate about distributed systems and Web3. He enjoys experimenting with all kinds of technologies to find new paths that leads to the better and faster results. With his love for sailing, led him to an endless search for freedom, even in the tech world. Over to you, Matt and Francisco, to take this forward.
Cheers. Thank you for that kind intro, Trisha. And welcome, everybody. Thank you for joining this session on Hedera development. I'm going to look forward to sharing with you a bit of an overview to start with. And then I'll be handing over to Francesco to take you through some awesome work that he's done around developing on Hedera as well, and to talk you through that, including a bit of a live coding session as well. So you'll actually get the benefit of some hands-on coding from this as well, which I think you'll find really useful. So as Trisha said, I'm just going to jump onto this one. I'm a full stack developer by trade, so I've been exactly where you are, and I know exactly some of the challenges that software development brings. I would welcome you to reach out and connect with me. I've got both my social profiles there that most folks kind of use, so feel free to connect with me on either Twitter or LinkedIn, and I'm always happy to engage and answer any questions that you might have through those channels too. So just moving through to the first section, I just want to contextualize where we're at in terms of the journey with the current era of digitization and what that looks like. If we kind of look to where we are right back in the 1970s, we were very much in a sort of paper-driven era sort of thing, really. And as we moved into the digital era, we got to leverage the benefits here of obviously digitization and the speed with which comes from that too. As we then moved forward through into the internet era instead, we then stepped up from speed as well into access and collaboration. So now, as well as being able to do things really quickly, we can obviously do that across the globe and collaborate with one another too, which would be kind of almost a bit mind-blowing to think what that might look like if the internet didn't exist right today. So and finally, with where we are right now, we've moved more into a trust era with digital information. So if you think about the questions that come to mind for you as we're looking at things through the lens of Web 2 and Web 3, you kind of start asking questions around, well, where does my data sit? Who owns my data? Who's in control of my data? And what kind of visibility do I have of data, and how trustworthy is that? Who's giving me an accurate picture? And that's realistically, an area that we came into as obviously the sort of Web3 DLT sort of side of tech started to evolve around 2009. Okay, so in terms of Hedera and where we fit into that, we're actually a third generation public distributed ledger technology, or DLT. And when you look at it through that lens, there's no wonder the fact that we're at where we're at in terms of performance right now and pricing and performance metrics. So if you think of Hedera as a third generation product, you can kind of look at it through the lens of the performance, and on screen now you can kind of see that Hedera can deliver 10,000 transactions per second plus, comparing that to some of the earlier generations tech, which is obviously far lower. Then looking at it through the pricing lens, we've obviously been able to introduce masses of efficiency by way of having further developed consensus mechanisms that are far quicker and far more energy efficient, that has allowed us to bring that transaction fee right down. And the interesting point here for Hedera too is that we actually fix our fees to the US dollar, not our own native currency. So the average transaction fee you see there is a combination of the transactions that have gone through our network, and I think you'll see that's massively low compared to where prior generations have been. And finally, as we think about the transaction confirmation time, this is, on average, I think if you looked at something like App Metrica, which is the dashboard for Hedera as a network right now, you would see the average confirmation time actually sits at around 4 seconds. That's really critical when you're thinking about building applications and you want your applications to be really responsive. You need that finality that's going to be able to provide you with that. That's one of the benefits of having, a third generation DLT sort of backing what you're doing with your applications. Now, if we do a cross comparison of third generation DLTs, you can see here some of the easy ones to compare to. So Polygon, Algorand, Ethereum there as well. And again, there's some really key differentiators here. I've talked to obviously the differences that existed between generations when we looked at it through the lens of transactions per second, costs, and average confirmation time. Even across all of these, you can see there's still significant differentiators with Hedera, but the one that always really blows my mind for me personally is the energy use side of it. We have a tiny, tiny energy footprint as a platform, and that makes us immensely kind of attractive for ESG use cases, where you don't want obviously a negative impact in terms of energy footprint with what you're developing. So we have a really kind of strong appeal on that front. And you couple that with the low fixed costs that we've got from an average network transaction fee point of view, and suddenly we're highly aligned to use cases that might have tremendously high throughput, and it's not too much of a leap to apply that to things like if you were looking at things like solar farm or wind farm tracking and being able to fire off lots of transactions around that, you would be able to do that very easily through our network with those low costs and low energy as well. So that's a really interesting differentiator when you're looking across the third generation DLTs. Now, just a quick touch on network topology for you as well. So I just want to walk through this to sort of give you a bit of context as to how Hedera is set up right now and what it sort of looks like in terms of using the network too. So right down the bottom center of this graphic, you can see the hash graph consensus. That currently is being run by 26 nodes with 1 node per governing council member. The hash graph consensus algorithm essentially powers all of those services that sit above it. So on there, you can see the consensus service. That's for verifiable timestamps and event ordering. We've got the token service, and that's really that enables you to manage fungible tokens and non-fungible tokens as well, and all of the operations that go along with that in terms of creating them, minting them, burning them, transferring them. We've also got obviously the smart contract service, and as I mentioned in the last talk, this is an EVM compatible service. It enables you to be able to deploy both existing and new Solidity contracts on Hedera, giving you all the flexibility of being able to use Solidity with all the efficiencies and fair ordering and low transaction fees of the Hedera network. Obviously, those 3 services there culminate to be known as the Hedera Network Services. Now, the network services, along with the nodes that operate those services, are all governed by our distributed governing council. We are tremendously fortunate enough to have 26 leading global organizations that sit on our governing council that help determine the strategic direction of the network. And that enables you to see there that, from a point of view of understanding how decisions are made for this network, you are not going to be dealing with a situation where those decisions are being monopolized by one company, a group of developers, or a node operator. You have 26 leading global organizations that all have equal vote contributing to the network decisions that need to be made. And I'll talk about this a little bit more in a moment. On top of those network services are where you will see application use cases being built. So there's a couple of examples on screen there at the moment. So process integrity, decentralized ID, asset tokenization, payments or micropayments, supply chain, as well as another one. And all of those use cases are what are then accessed by the end users, be they individuals, enterprises, governments, or devices such as IoT devices, that type of thing too. I'm going to touch a little bit on the governance side of Hedera as well, because this is something, as I said, that is very unique to our network. We have essentially separated consensus from governance to ensure that the governance and the decisions that lead to how changes are made on the network are quite separate from obviously the technology and the mechanism of arriving at consensus underneath it. We want to make sure that the decisions on how those changes to the network come about are being done in a fair and effective way. So as it stands today, we have 39 seats on our governing council, and 26 of those are currently occupied. Obviously, as we move forward, we gradually include and add further council members to those seats. We have, as it stands right now, again, 11 unique industries, including universities across major markets covered with those members that are there right now. And each of those members, as I mentioned from the graphic before, is required to run a network node. It's part of what makes the initial deployment or phase one of the deployment of the Hedera network secure and robust in terms of knowing that it's being run by trusted sources. The members, as it says there, are not compensated beyond the network node payments. Now, a really key thing that comes into this, and that you might sort of have a question of yourself, is that those members all have absolutely equal votes. And that's really important because it needs to be a fair process in terms of how decisions are being made. We have committees within the governing council as well that look after certain things like membership or new members coming into the governing council, technical steering and product committees to look after the product and the network decisions, and the other three that are listed underneath there too. Now, one of the things that I personally like about the governing council model is that with the typical kind of approach of having a term limitation, you can have 3 years maximum, up to 2 consecutive terms. But the nice part then is that when it is the end of a council member's seat on our council, those governing council members will then find a replacement for us, meaning that we have that benefit of being able to introduce more experience, more decentralization into the way that we're operating and making decisions about the network. In terms of the types of decisions that those council members help to make for the network, we might be looking at things like feature decisions, like what is actually included or not included in the network, the product roadmap. So when are those features actually included in terms of development, and what does that look like for us in terms of we break up that sort of introduction over the year? What type of fee model we actually use on a network, things like node incentives, the stake and rewards, which is something that is coming to fruition right now on Hedera, and obviously treasury management. These are really important decisions, right? So you obviously want to make sure that those decisions are being handled by the types of organizations that we've got on our council and being done in an effective and efficient and fair way. Hedera has always had a really strong view on governance and having strong governance. And to start with, as with many startups and innovations, the control for that initially started in a place of having patents in place to protect the technology and to ensure that it wasn't sort of copied and that type of thing. As it's matured and as we've traveled on our journey, we've been able to introduce more technical controls to ensure that isn't the case anyway. And to further kind of move towards the decentralized kind of model, we've actually open sourced the technology too under an Apache 2.0 license. Underpinning a lot of what has really sat behind some of that thinking, there's been a promise of not forking the network. For anybody that has built an application and has spent the time that is required to invest in that and the cost behind it, it's really important to us that you know that you have a really stable network to build on when you build on Hedera. You don't want to be in a position where a network forks and you're left competing with, left dealing with competing chains or competing currencies. It's an absolute nightmare. So with Hedera, we've always come at this from the place of going, this network will not fork, and you are trusted with the stability of knowing that you're going to have a consistency there to continue building your product on. That additional bonus to that is obviously we ensure that we can have simultaneous software upgrades by keeping that consistency and stability in place. Now, I would like to show you next some of the leading global organizations that we have on our governing council to give you a bit of a sense of the type and caliber of organization that is with Hedera on our journey. I'm going to let you have a quick look at that there, but I can just call out a few if I can. From a materials point of view, in the materials sector, we've got Avery Dennison. Industrials, we've got Boeing. Obviously, from an information technology point of view, we've got FIS themselves here. Thank you, guys. IBM, ServiceNow, Wipro as well. We've got such a massive collection here. It's untrue. University from we've got IIT Madras, UCL, LSE. The most recent governing council member was actually in the gaming and entertainment space, which was Ubisoft. So thank you guys for joining us on that journey. That was cool. And obviously from a location point of view, we've got a massive number of countries covered here. So we're massively distributed too. If I just run through these, it'll give you a sense of it. You've got the likes of USA, Singapore, Germany, UK, France, Australia, India, South Korea, Brazil, Japan, South Africa, and Kuwait in there too. Hedera has knowingly decentralized the governance of its network. And, like I said before, a critical part of that is separating the governance from consensus so that you know that you have that fairness of how changes are being introduced to the network. And I'd just like to contextualize a little bit, perhaps, too, obviously, in terms of our relationship with FIS, as Tushar said, we are a partner with FIS. They're on our governing council. FIS themselves obviously are doing some exploration with Hedera right now and are working with Hashport as well to look at how you can obviously look to move digital assets between chains, and they're utilizing Hashport as an enterprise grade public utility that helps them with that too. So it's great to see both, the council members playing such an important role from a governance perspective, but also utilizing the network and being able to explore how they can further their own business endeavors on what we're providing too. Now, in terms of giving you a little bit of a sense of what the ecosystem currently looks like from a Hedera point of view, we have over 14,000 developers within our community, be they attending hackathons, meetups, and actively participating within conversations within our Discord, etc. too. We've got literally over 100 applications in production on Hedera mainnet that has obviously been open access since 2019. We have 7 million plus transactions a day, and that's far surpassing obviously the daily transaction volume, like I said there on Ethereum too. We're actually one of the highest used DLTs out there right now. Obviously, it's very exciting that we surpassed Ethereum, like I said too. And we've actually gone even above the 830 now. I think we went over 1 million accounts on mainnet recently too. So we've grown massively since obviously the mainnet was open access in 2019. And we've got a really healthy ecosystem for you guys to be able to join and to develop alongside as well. So I would really encourage you to have a look at what we've got available to you from Hedera in terms of developer and tutorials and onboarding as well. And as part of a taster for that, I want to basically make sure that you've got access to some hands-on experience as part of this session. So I'm going to hand over to Francesco next, and we're just going to swap screens because Francesco is going to be doing a little bit of a workshop with you and, like I said, some hands-on coding. So I hope that overview was useful. And Francesco, I'll just let you jump in and grab the screen if that's okay, so you can jump into doing your hands-on side of things.
Thank you, Matt. All right, hope you're seeing my presentation. So hi everyone. The first thing I want to do is give you a brief introduction to myself. So I started in the Web 2 as a freelancer when I was 15, and I started in getting in touch with Web 3, and the first experience I had is losing an amount of money, a very big amount of money. And then I also had a problem with fees. So I started paying fees with a couple of other networks. And then I started, I started to know details. I started to approach details of the Web3 ecosystem. And when I encountered Hedera for the first time, I was completely speechless, and I decided that this is the path I want to take. So I right now I'm a developer evangelist in the DevRel team of Hedera, and I usually try to facilitate the learning path for Web 2 and also other Web 3 developers that want to enter this world easily and avoid making the same mistakes I made. If you want to connect with me, you can find me on Twitter and also on LinkedIn. And let's start with the workshop. So these are some topics we're going to cover. So the first one is an introduction to Hedera development. Then we're going through an overview of all the core concepts of Hedera, a little bit of an introduction to the main services we are offering right now. And I will also show you some use cases. And then we'll switch to a live coding session. So the first thing I want to introduce, give you an overview of Hedera. So we're actually throttling to up to 10,000 TPS transaction per second. And we are offering a platform completely secure thanks to the asynchronous Byzantine fault tolerance system and our Ashcraft consensus algorithm. So in terms of fees, we actually have an average of $0.0001 fees. And this is a very, very, very interesting feature. You can actually predict your fees and avoid getting weird gifts during your Web3 learning path. We, as Matt told you before, we actually have a governing council that is actually running consensus nodes around the world. And right now we have the lowest carbon footprint out there, and we are trying to maintain. We are going to maintain this feature forever. So we are a carbon negative infrastructure. So let's start talking about different networks we have, and then the different networks you can use to approach the Hedera ecosystem. So the first thing, the first network is mainnet. Mainnet is actually composed of consensus nodes, and consensus nodes are maintained by the governing council. They usually are used to valid transactions, and to pay transactions inside of the mainnet, you use the native cryptocurrency of Hedera that is called HBAR. You can use the HBAR cryptocurrency to pay transactions and also queries. We also have the mirrornet, and the mirrornet works together with the mainnet. So they're actually sending information to each other. While the mainnet is dealing with the consensus algorithm and transaction validation, the mirror net is maintaining a history of the transactions. So you dividing these features, you're actually reducing the event like bottlenecks inside of the network. We are also offering on the MirrorNet a pub sub, publish and subscribe feature that I will talk about later. So we also have 3 other networks. The first one is the local net. And the local net is actually a recent introduction inside of the Hedera ecosystem. You can actually run a consensus and a mirror node in your local machine without eventually getting interrupted. For example, if you're working on the testnet, sometimes people are running like hardcore tasks on the testnet, and they're creating, they're slowing the network, the testnet network, as the testnet is, we as Swords Labs, we're running the testnet. So I will show you how to set up a local network in the next slide. But first, let's see the testnet and preview. So the testnet is a copy of the mainnet, essentially. It's running the same code as the mainnet, and it's very suitable network for pre-production. If you want to test and you're almost ready to push your code and use your code on the mainnet. Some of the features of the testnet are you're actually getting 10,000 HBARs refill every 24 hours because you don't actually have to pay the testnet. It's completely free. And the testnet is also being resetted on a quarterly basis. So on a quarterly basis, we are deleting every information inside of the testnet to keep that light and fast, and also avoiding power consumption and resources consumption. We also have the PreviewNet, and the PreviewNet is actually running a code under development. So this is more unstable. If you want to try to use new features, upcoming features, then you can use the PreviewNet. So this is the first example to actually set up a local network, a local node inside of your machine. The first thing you have to do, if you want to proceed with this path, obviously, you can also use the testnet, no problem at all. The first thing you have to do is cloning our Hedera local node repo. And then after that, you have to redirect inside of the cloned repo, and you have to use the command docker compose to actually create the Docker machine. And you obviously have to download Docker in order to use this. After that, and after downloading Docker and after using the docker compose command, you will actually have a running consensus node and a running mirror node inside of your local machine. To set up a node to connect to your local node, this is an example using JS SDK. So this is JavaScript. You can actually use Java or .NET or Go, but in these examples, you will see JavaScript. The first thing is I'm setting a node, and in this case, I'm connecting to the local host, and the port is 50211. That is the port for the consensus node. And then I'm setting up a client. The client is the object that permits of connecting with the network. So I'm specifying the node I just created, and I also specifying the localhost and the port 5600. That is the mirror node. So I'm actually creating an easy. I'm using the client to create an easy way to interact with the local node you just deployed. So the second, the last snippet you see right here is the setting of an operator. So an operator is the account responsible for every payment and every transaction you are making inside of your code. And the operator is actually paying the fees of every transaction. And don't worry, you can actually change the operator during your script and change every information you need. If you want to change the payer of your fees, you can change it with no problems at all. So right now I'm setting an operator with an account ID that is 0.0.2 and a private key. You can actually, I'm showing you the private key because there's no problem at all. This private key is actually a hard-coded constant that you need to set up. You need to set if you are setting up a local node. So these are the other ways of connecting to other networks. This is usually a good practice, but you can actually use different ways to do that. I'm actually creating a .env file, and inside of the .env file, I'm putting my credentials for the operator or for any account, basically any account you need. If you are familiar with JavaScript, you can actually use library called .env to interact with this type of files easily. And as you can see, to import my credential inside of my JavaScript code, I just use the process.env.operator ID. That is the way of using .env, the .env library. And I'm actually using the account ID and private key .from string function to create an account ID and private key object. Now, again, I'm setting a client, and when I'm setting a client, I'm actually using a different syntax than before. So before I was using for network, and now you can use for testnet, for mainnet, or for previewnet if you want to use these networks. The last thing is actually setting the operator. So you just proceed as before, you just use client.setOperator. This is like step one to start developing with the Hedera ecosystem. So let's talk a little about accounts. Inside of Hedera, you can actually have, you can create accounts, obviously, to interact and make transactions. So a difference is if you never used a Web3 a chain or a network, then it's okay. This might sound normal, but usually on other networks, you actually have a private key and the public key, and your public key is actually the way to interact with that account. So to simplify this account interaction, you actually introduced a different way of representing an account. That is called account ID. As you can see, there's an example right there, and the account ID is 0.0 and a number. That is just a random number, but the 0 and the other 0 are actually representing the realm and the shard. And the shard is not active right now, but in the future will be active, and using a multi-shard system can actually increase the transaction per second of the whole network. So to create accounts, you have two methods available. The first one is using an existing account to create the account you want, and the second method is actually more complex, but is using an alias, an account alias, and actually an account alias is a public key address, an immutable public key address to actually create another account that you can only set on account creation. So I usually use the first one. That is the simpler one if you're approaching this type of technology. And why you need an existing account? Generally, you need an existing account because when you create another account, you're transferring an initial balance, and that initial balance is mandatory to create the new account. So inside of an account object, you have the account ID, the keys, and the keys you can have a single keys simple key, or actually a key list. So you can actually introduce that. Inside of an account object, you can also find token balance, and the token balance is relative to not only HBARs, so the native cryptocurrency, but you can also see the token you created with HTS, the Hedera token service. So NFTs and also FTs and fungible and non-fungible tokens. There's also another field called automatic associations. So I want to stop for a second here and show you what associations is actually in our system. So we usually use associations because we introduced this feature because when you are on other networks, you can, if you give your public key, you post your public key on a blog, for example, on Reddit, I don't know, everywhere. People can actually send you tokens you don't want to have. So they can actually send a crazy amount of token with no value at all. So we introduce associations to avoid that. So when someone transfer a token to you, you need to associate that token ID before receiving that token. So then we introduce also the automatic associations to avoid performing a token associate function every time. So you can set a number of automatic associate, for example, 10, and then you'll receive 10 tokens without even the need to associate the token to your account. Then there's a field called account alias that is relative to the alias. I told you before, the immutable key, public key, then live hashes. And I just want to let you know that it's not enabled yet, but we're actually working on expiration and rent, for example. So smart contracts and files inside of our network are actually using storage. So if you publish a smart contract and you leave it there, it's consuming storage and it's useless basically. So we introduce expiration and rent to delete smart contracts automatically if you are not paying this expiration fee. And this is just like a little small fee with no impact at all. But you can actually, for example, make your smart contract itself pay this fee with no worries. And I think this is an important thing to remember when you're working with the network in the future. You can also create accounts using, we have simpler methods to create accounts. You can actually use wallets. We have wallets like Hashback, for example, to simply create accounts without using the JavaScript, for example, or using a script. You can actually create those from supported wallets. So let's switch to keys and signatures. So we have two supported systems for generating keys inside of our system, of our network. So there's the ED25519 and the ECDSA. The key can also be a smart contract ID, and you can actually create more complex systems of keys. So you actually need a private key, and those systems are for generating a private key. You need those to sign a transaction. So if you are transferring a cryptocurrency, for example, from me to Matt, I need to sign the transaction, obviously, so he can't steal my money. So we have different systems. We have complex systems like threshold key, and a threshold key is when you're actually when you have for example a multi-signature transaction that needs multiple signatures. If you set a threshold key, you can actually use that threshold key only to execute that transaction. If you have a key list, for example, so a list of multiple private keys, you have to actually sign with all that keys before that transaction is executed. You also can have nested key list and more complex situation where you have a key list inside of a key list inside of a key list with a threshold key with a nested key list, and you can really have so many possibilities to set up keys and key lists and multiple more complex systems. So about the signatures must match the key structure. What does that mean? So obviously, if you have a certain structure, you're using a threshold key or a key list, you have to sign using those keys relative to that transaction or that account, obviously. So this is an example of an account creation using code. And this is JavaScript SDK, so I hope you're familiar with this. In here, I'm importing the Hashgraph library, and I'm using free main function for that. The first thing, I'm generating the private key, and as you can see, I'm using a function called generate ed25519. And with that function, you actually have a private key ready to go. And after that, you can execute an account create transaction. But before doing that, you have to specify the initial balance to create that account, as I told you before, in this case, 10 HBars. And then you also have to specify the key, in this case, the public key, obviously. So you can get the public key from the private key you just created. That is an object containing the public key, and you set a key for that account, and then you execute the function. So you're executing the function, as you can see, with .execute, and inside of those round brackets, you can see there's the client. So the client is the object you created before, and in this case, you're actually paying with the operator the transaction to create the account, and you're also the operator is also paying the HBars for the initial balance. The last step is getting the receipt. So getting the receipt is a way to get information of the transaction. There are also other methods to get that. You can actually get a record that is a more detailed information, and there's a coming soon feature that is state proof. You can actually get state proof of that transaction. So let's see transactions and queries. So first of all, transactions. When you submit and execute a transaction, you're actually sending the transaction to a consensus node to submit and create an event. Create an event to add to the Hashgraph, for example. And for each transaction, you have fees and associated fees based on the consumption of that transaction. And you can also set a max transaction fee to avoid paying too much, or maybe that is your amount. That is the amount you're willing to pay, and you can actually set that. Inside of a transaction object, first of all, you have a node account. So the node account is the account the consensus node account you're sending the transaction to. So for example, if you have 0.0.2, that is the account of a consensus node, you will see that account number in there. Then there's the transaction ID, and the transaction ID have two main parts. So the first part is the account number of the operator, so the one executing the account, executing the transaction, and the second part is the timestamp of that specific transaction. Then you have a field dedicated to the transaction fee, then a valid duration, a memo. A memo is actually a 100 bytes string text. So you can actually set a text when submitting a transaction. For example, I recently sent HBars to my brother, and to do that, I actually set a memo, a funny memo, so he knew I was his brother. Then we have another field called transaction, and in this case, you have the type of transaction you are executing at that moment, and all the signatures required for that transaction to be executed. So this could be a key list, as I told you before, a threshold key, and or a single key, for example. Then you can also have scheduled transactions, and scheduled transactions are, I think, a good way and are ideal for multi-signature transactions. So you can actually queue a transaction and wait for all the participants, so all the private keys, to sign the transactions in order to be executed. And this, for example, is a topic create transactions and transaction. I'm going to talk about topic and topic creation after. This is one of our services. This is the consensus service. And as you can see, I'm importing again the Hashgraph library. I'm setting up the client with my account ID and my private key. I'm not going to show you that. And I'm actually executing the topic create transaction. We don't need any particular, in this case, there's no need for any parameter to specify. And then I get the receipt, and from the receipt, I can get the topic ID. All right, let's switch to queries. So queries are actually another way to get information and current and certain aspects of the consensus state. So let's say you want to get your balance, your account balance, then you can use a query to get that balance easily. Generally, some of the queries are free, but some of them have an associated fee, and you cannot get back if your HBars if you overpay that those fees. So as an alternative, we created the Mirror Node API. So as I told you before, the MirrorNet is actually maintaining the history, and to interact with the MirrorNet, we created the MirrorNet API to interact with the MirrorNet and get information for free without any fee. So you have a link and you can perform a GET request simply by, for example, on JavaScript using Axios to interact with that specific URL. So this is an example of the account balance query to actually get, in this case, HBar amount, HBar balance. I'm setting again the client for testnet. I'm setting the operator, and I'm specifying in the account balance query function the account ID, my account ID, for example, and I'm executing using the client. So I will get back the HBar amount of my account. And so you can actually do the same process using MirrorNode API. So you can actually get the account balance from the MirrorNode API with no fees associated. I don't think the account balance query have associated fees, but some of these operations usually have fees. So now I want to talk about the networks, the main networks we have. So probably, the Hedera network services, and probably this diagram might show you this diagram, this topology, network topology before. So in here we actually have 3 services the consensus service, the token service, and the smart contract service. We actually have 2 more services. We consider cryptocurrency, for example, the native cryptocurrency as a service, and also the file service that is supporting smart contract service. Let's start with the consensus service. So the consensus service is actually a pub sub system in which you can create topics and you can subscribe to those topics and send messages. And the good thing about this service is messages are put into a consensus order and with a timestamp. So you can actually have a proof of the order in which those messages are sent. You can actually have, for example, people sending messages to the consensus, using the consensus service to get to subscribe to a topic and use that topic to, I don't know, there are a couple of use cases I will show you after, but you can actually track and have transparency. And the good thing about this service are actually the low fees. So as I told you before, we have a high speed and we are a very scalable platform network. So you can actually use fees, you can actually pay low fees for this service. So we also, sorry, I also forgot about audit logs. So we also have the messages are cryptographically tied together, and we are actually running hash to provide an auditable tamper-proof log of history. So you can be sure that those messages are not modified, and you have a whole history of messages submitted. This is a diagram showing you some of the transactions and queries that are on the Hedera consensus service. So for example, transaction, we have topic create transaction, topic update transaction, topic message submit transaction, and topic delete. And we also have queries. I want to just specify that to make sure that when you're developing using these functions, these transactions, for example, to check out the documentation, the Hedera documentation, because sometimes you might be thinking, yes, you told me that consensus is you cannot interact with the history of messages. You can that is an immutable thing. You can actually have that forever, but actually you can delete a topic, and the only way to do that is by specifying a submit key, an admin key. So when you actually build using this system, you have to check out what are the main keys you need, and also with the other services. So you might need, for example, you can also have a submit key inside of the consensus service to avoid you're not familiar with maybe to submit their messages into your topic. You want only certain people to submit those messages into your topic. So you can actually use different keys to do that. And I think that is a good way to modify, for example, a topic. But sometimes maybe you need to avoid setting that key, for example, to guarantee to your users trust. So if you set an admin key and you delete a topic, you lose trust, for example. And usually when I build examples, I try to not set an admin key to guarantee trust, to show an example of how a trustless workflow can have a positive impact instead of a standard workflow. So let's start talking about the token service. The token service is for creating fungible and non-fungible tokens. You can actually tokenize assets, and we are guaranteeing performance, security, stability, and the most important thing, low and predictable fees. So the correlated to what I've experienced, it was about a token, and for transferring a token, I had $60 fees on a $70 balance. So after that experience, I really started enjoying the Hedera ecosystem and how to actually use non-fungible and fungible tokens to offer a different way to interact with tokens. So, for example, we have scheduled transactions to interact with can interact with Hedera token service. We have every token inside of Hedera that you create using the SDK is actually native to Hedera. So the good thing is they're very fast. There is no high fee on that, and you can actually make sure that they're very, very fast with no problems at all. Also in the internal transaction, if you're sending your token to someone, you can be sure that it is extremely fast. We also have in here we have different keys. As I told you before, there are a very high number of keys you can set when using the token service. So you can actually introduce KYC, the know your customer. So sometimes you want to know the person that are transferring tokens, and with the know your customer keys, you can actually select an amount of people that can use that token, transfer that token, interact with that token, and that is useful in some cases. And we also have a freeze key, for example, to avoid certain accounts to interact with the token service and freeze those. You can also have a supply key, for example, if you want to mint tokens, so create new tokens. If you're not setting a supply key, for example, you cannot mint new tokens and create new tokens. You can transfer and do whatever you like using the token service. So we are also guaranteeing network stability for sure, and we also guarantee no forks. So you can actually you can feel safe using our token service, and it's completely stable, secure, and I think it's a good way of starting also with the Hedera ecosystem. So these are some transactions and queries of the token service. As you can see, there are multiple transactions in there, and we also have queries. Remember that you can also use Mirror Node API also for the Hedera token service. So the transactions, as you can see, there are token create transaction, update, delete, and again, you might think that a token should be immutable, but again, can be immutable if you are not setting an admin key. If you're setting an admin key, that could be mutable. You have associate, disassociate, dissociate, mint, burn, wipe, and we will see in detail a little bit a complete life cycle of a token, of a fungible token, in a live coding session after the end of the presentation. So let's start with smart contracts. So smart contracts are on Hedera are EVM compatible. So we are actually using Solidity as a main programming language for contracts. And our current version of smart contracts is 2.0. So the new version actually enables developers to interact with the Hedera token service from the smart contracts. And last year, we also migrated from the Ethereum EVM to the Hyperledger Bezo EVM that provides the last support of Solidity. And we can also guarantee with smart contracts, we can guarantee that all the transactions, all the execution of smart contracts are executed in order that they're received on, and not based on the amount of gas you paid when you were executing the contract. There's also no need to pay an extra to be included in the earlier history. You can also have admin keys in smart contracts to have administrative power and to manage your contract, to actually change your contract, to change, for example, to update your contract by, I don't know, doing everything you want. But again, you're removing trust when you keep an admin key as a user. So as you can see right here, we are live on mainnet with Smart Contract 2.0 from Q1 2022. And these contracts are completely secure, leaderless. If you want, they have a leaderless architecture. And the most important thing is we are actually, by deploying smart contracts on Hedera, on the Hedera network, all contracts are sustainable, and the offset is by Hedera is carbon negative. So we have a carbon negative offset. So sorry, carbon negative network. The good thing is we also have low fees on smart contracts. Smart contracts are actually like a trigger function, for example, on a cloud service. But this trigger function, these programs you're running, they have very low cost when it comes to fees, and that is a very good feature to have. We are also ensuring that we have fast transactions, because sometimes you might try to execute a smart contract on other networks, and you have to wait for example, for the next block to be mined in other networks. And in this case, you're not waiting. Your function can be, your smart contract can be executed in a couple of seconds. And that is a very good feature to have. These are some examples. You can find other examples on the Hedera documentation of the transactions and queries available. So we have contract create, contract delete on the right, and other queries. And remember, you can use Mirror Node API again to avoid paying fees. All right, so this is the native cryptocurrency service, so the HBAR service. So right now we are achieving 10,000 transaction per second on the cryptocurrency service, but keep in mind that we are throttling those transactions. You can actually have an higher TPS rate, but that is possible only with sharding, and one day we will increase the throttle of the net, so we can actually reach higher levels potentially. So as I told you before, we also have predictable fees. You can actually check out the fee table on our website, and we also have a fee prediction table system that you can use on our website to see if you're executing a certain function, for example, to avoid getting high fees without knowing why. You can actually use tables and predictor. So you can be sure that when executing a transfer, for example, of HBARs, an HBAR transaction inside of our network, you can be sure that within 3 to 5 seconds will achieve finality. And that means submitting to the consensus node and transaction validation, and then the transaction going to the mirror node that tracks the history of the transaction. So these are some examples of the cryptocurrency service. So as you can see, there's the function we used before, the account create transaction, and you can also update your account, delete your account, for example, and use queries. So there are some case studies that we can see that you can take as an inspiration to build your solution, for example. Let's start with payments. So we have the Chopra Foundation. So this is a very, very interesting use of the HTS, the Hedera token service. So they're actually using the Hedera token service to increase mental health and support mental health around the world. And they are actually partnering with Hedera to create a decentralized platform. And the main thing is they're trying to democratize the access to trusted resources to support mental health worldwide. And that is a very good use case. We also have Tune.fm, and Tune.fm, I think Matt talked about Tune.fm in the launch event. And this is a very interesting use case. They're using HTS, so the Hedera token service, to tokenize the music economy. So as you know, there are some problems with copyrights and the uses of music created by artists. And this is a very good way to remove intermediates and use a token service to implement a micro payment system to use music of artists around the world. Then we have FPOS. So they are using the Hedera token service to facilitate payments and micropayments and providing an alternative to the traditional online system. So usually when you go on a website, you have traditional payment systems, credit cards, debit cards, Apple Pay, and all those systems, but they're trying to implement a way to use, they implemented a way to use payments and micropayments using the Hedera token service. So let's switch to supply chain. And this is a very good example and use for the Hedera consensus service. So the Everywhere is using the Hedera consensus service to monitor the temperature of some assets. So for example, there's been a problem on COVID-19 vaccines on temperature. So when COVID-19 vaccines reach a low temperature, you can't actually use them anymore. So to monitor that and track that and trace and track their temperature, you can actually use the consensus service to keep an immutable and tamper-proof record of sensors when transferring, for example, COVID-19 vaccines from one country to another. So Acquire is using, again, the Hedera Consensus Service to avoid drug shortages. So because of the drug shortages, for example, in the United States, there's been an average of 198 shortages every year happening, drug shortages. So to avoid repeating those errors, and repeating the errors is actually not worrying about the problem, they try to use the Hedera Consensus Service to avoid those situations and use track and trace the drug shortages and to avoid them, and trying to regulate that by adding reports and using supply. Basically,
it was tracking the amount of the product, essentially. That's all right. No, it's okay. I'll just add to it what Francesco was saying. So you're basically adding supply chain management to the Hedera Consensus Service, so that you've got visibility of what supply of a certain product is available when, and it enables, obviously, those involved with the supply chain to track kind of the quantities of that product going through it, and to make sure that they can mitigate it if there's any reduction in the amount of supply available, that they can see that it's immutable, they can address it and obviously increase supply as they need to. So it's a good way of being able to mitigate kind of supply chain issues.
Thank you. Then let's switch to Entrust, and Entrust is using HCS, so the Hedera Consensus Service, to trace and track the agricultural products. So they're trying to reduce the fraud inside of the market. So they noticed that there is a problem on the market. They estimated at $3 billion fraudulent wine each year. So they try to reduce that by providing a trusted mechanism using the Hedera Consensus Service to trace every supply of wine, for example, and all the supply chain for agricultural products. Then we have Suku and Suku Omni. So Suku Omni is using the Hedera Consensus Service for guarantee the product authenticity. So this is they're using low fees, essentially our low fees, they're using the consensus service with low fees to actually be sure that a product is authentic end to end. So they're monitoring the supply chain on products, on various type of products. Then we have sustainability and energy. So Power Transition is a company using the Hedera token service to create a micro payment system to make customers trade electricity and pay using the micropayments, using the Hedera token service. So they use this system to have a stability, to have low latency in payments, and they can be sure that Hedera is providing that, and also predictable fees, for example, in transactions. So then we can switch to data integrity, and we have Safe. And Safe is actually a good way of interacting with customers in the healthcare world. So they're trying to use, they have 150,000 users, and they want to record health, population health, and increase healthcare data in real time. And they obviously need, when taking information, they obviously need to guarantee privacy during by getting those informations. And to do that, they can actually use Hedera to simplify that system. Then we have ad stacks. And so the problem in the digital advertising is that there are fraud and trust issues. So also 75% of fees are goes to the intermediaries. So they are trying to delete from the equation intermediaries and leveraging our system, Hedera, to actually build a platform to track, trace, verify advertising events, and also provide security and that resilience, scalability, transparency. That is super important. And I think this is a very good use case. Then we have the coupon bureau. So they're trying to they're trying to use the consensus service to actually create coupons. And for example, they're trying to allow third-party validation and audit capabilities among stakeholders. So let's go forward. Tokenized assets. We have Infinite. This is powered by Suku. And this is another way to use the Hedera token service by creating NFTs and tokenizing, for example, other physical products to guarantee the authenticity of the product they are selling, and also the ownership of that product. And this is a very good way, a very good use of Hedera token service to actually track to avoid getting fake products and on the market. All right, then there's Unibright, and Unibright actually offers utilizes they use HTS, so the Hedera token service, to deliver and so to introduce a lower cost and performance to interact and tokenize, to interact with the tokenized assets and also interact with tokenized assets. So they need a more secure and more fast system, and they're actually using the network for that and the Hedera token service. So I think we can start by building. So I want to start in a couple of minutes. We'll start the coding session. So I don't know if Matt want to add something before starting creating on these companies, or if you're fine with that.
Cheers, Francesco. Look, now I'd just add in that obviously there's a whole heap of different use cases there, but what I want you to take away from it from a development point of view is that the consensus service essentially provides you with a facility to create immutable logs of data. And when you think of that, that's for some of the use cases that largely involve compliance data. So think about it in terms of that you want to log data that will be available to regulators and that they can trust the timestamp that is against that data, the order in which that data has been presented can be entirely trusted because essentially it is done on a distributed ledger that you don't control as part of your application, of course. That said, it doesn't mean that you can't have hybrid solutions. So you can utilize the consensus service, for example, with both Web 2 and Web 3 solutions. So, you know, if you looked at it through the lens of a Web 2 solution that might involve compliance data, you know, it might be that you log certain data to the consensus service to provide that immutability and to provide that kind of integrity of event ordering and timestamps. But equally, you might have off-chain data that's just stored within your own infrastructure that is maintaining obviously privacy or sensitivity of data that you don't want to put on chain. So it doesn't have to be an either or with utilizing that type of product. You can utilize a consensus service for auditable data and still keep data off chain if you want to. Then with some of the HTS kind of use cases that we walked through as well, obviously, you know, you've got the ability there to be able to create unique non-fungible tokens to represent the authenticity of certain assets. So you saw examples there of different kind of perhaps brand usages of them. If you think of that in terms of a supply chain, it might be that you are tagging a physical product with content that is part of a NFT, so that you can correlate that physical product to the NFT and therefore correlate on chain the authenticity of that physical product. It's a way of you, again, maintaining integrity from a physical product through to something that is digital, that is verifiable, that is distributed, so that there is a guaranteed kind of authenticity and inherent trust that is then apparent when it is in that trustless environment. So there's lots of different ways that you can look at this, and it is a bit of a paradigm shift when you're looking at it from a development point of view. It is something that will be a little bit new and a little bit different than perhaps you may have experienced if you're approaching this from a Web 2 point of view. So keep that in mind, but it doesn't mean that, you know, you throw everything that you've done before away. It's purely that this is a whole new set of tools and services that you can use to complement perhaps existing products that you've got or build new products. And over time, you know, be able to leverage them more and more to provide that kind of authenticity and trust that goes hand in hand with it being a distributed ledger that you're logging that information to. Other than that, I just wanted to share that for a little bit of extra clarity to you. And obviously, I'm just going to flag as well that whilst Francesco is going through this information with you, I am keeping an eye on both the Q&A, and I'm dropping a few polls into the virtual platform as well. So if you haven't checked those areas out yet, then please have a look at some of the polls that are popped in there. And also feel free to drop questions in the Q&A. And as Francesco is going through, I will be responding in there. And if I can't answer you straight away, then I will certainly find the information and be able to come back to you on it. So keep that in mind. Other than that, I'll hand back over to you, Francesco, and feel free to carry on with the build side of this.
Okay, thank you, Matt. So if you're ready to build on Hedera, then you can start by, if you want, you can build with me. You can also see while I'm creating a fungible token. That's totally up to you. So the first step to start developing using the Hedera network is developing on the Hedera network is creating an account. So as I told you, there are testnet and mainnet and previewnet, and in this case, I'll be using the testnet. Obviously, I don't want to pay real money for an example. So you can start by creating your testnet account on our website, on our portal. You can find the link down below, down in the bottom of the image. And if you want, you can also set up a local network. This might be the faster way, and using the local network might be longer. So the important thing is you actually need a private key and an account ID. That's all you need. So if you are creating a local node on your machine, or creating a testnet account on the portal, the important thing is you actually get your private key and your account ID, as you will need those in the live coding session. The step 2 is choose your SDK. So you can actually use one of these SDKs available. You have Java, JavaScript, Go, and .NET. We actually have more SDKs that are community managed. We have Rust, I think, Python, C, and other solutions. I will be using JavaScript and the JS SDK in this example. So I will show you how to set up your environment, but if you want to have more details about how to set up an environment, you can go to this website, to our website in this environment setup page.
And I'll just add to that as well, Francesco, just to provide an extra little bit of clarity, that when you are obviously interfacing with the network, and as Francesco's kind of shared, there's the different nets that are available, whether it's mainnet, testnet, whether it's preview, whether it's local, particularly in terms of those sort of different environments, that the accounts are relative to that as well. So, you know, when you are testing on testnet, for example, and you've created an account using that previous sort of slide that showed you could register via the portal, which I'd encourage you to do, because there's no cost, and it's nice and easy to do that, to sort of get started. That when you kind of migrate then from being on testnet to perhaps promoting it over to mainnet for production, you would obviously need to create a mainnet account. They are separate in that sort of sense, and you do need to make sure that you've got accounts that are relative to the network that you're connecting to. I just wanted to share that for clarity, just so it was really clear.
Thank you. So let's start by I'm gonna interrupt sharing my screen now, and I'm gonna share my IDE. So first, I'm gonna share my terminal for a moment. I probably need to increase the size of the font, or can you see big enough?
Yeah, the size is okay, Francesco, to be honest. It's certainly okay for me, at least.
Okay, so I made a directory called FIS Ideaton to start, and the first thing I want to do is create a directory. I'm going to call this token example. You can call this whatever you want, obviously. And I'm going to enter the directory. So in this empty directory, I'm going to start an npm a Node.js project. So I'm going to use npm init to start a new project. Okay, version okay, description, entry point, index. You can set all these features as you like. For example, I'm going to set my name as author. All right, so we now have a package.json ready. And we can start by importing our main libraries, the libraries we will need. So I use npm install, and the first thing is importing the Hashgraph SDK library. Yeah, so I think my connection is slow, but we'll be ready in a second. So while this is loading, I'm gonna create a new window. I'm using VS Code as an IDE. I will share my entire screen on my entire screen. So you can see the IDE. So the other library we need is .env to interact with the .env file. Sorry. There we go. And right now we have a node modules folder, a package.json containing our dependencies, and we can now create the index.js file. And I'm gonna create also the .env file. Perfect. So now we can open that folder. Okay. So this is our project. This is what we will start with. And the first thing you need to do is setting up your .env file. So usually I call this operator ID, but you can call this whatever you want. You're going to set an operator ID, that will be your account ID, and an operator key. This will be the private key. And you just had here your credentials. Like for example, your account could be 0.0 and a number, and your private key that will be 302 and a long number. So let's start creating our project, our fungible token creation and life cycle of a fungible token. So you're going to learn how to actually interact in almost any way possible with a fungible token, but this is just for learning purposes. You actually don't have to do all this at once. So the first thing I'm gonna do is importing the .env library and configuring that like this. So after that, I'm gonna declare my operator ID and operator key, and you can already parse those to, you can create an account ID object using the from string method, and by using .env to import that credential from your .env file. So, and you can also add your key, your operator key, and by creating the private key object from with from string process and operator key. So you just imported your credentials from here. Now I'm gonna declare the client, create the client as client. I'm gonna use for testnet, but you can actually use local network, and the operator. So they're responsible for transaction fees, basically. Good. So gonna do some refactoring here. So now we can create, for the example, just an arrow function, a main arrow function, for example. And we call the function to be executed, so we can test that. Perfect. So now we have whole ready to interact. I don't have the operator ID and key, obviously, in here, because I don't want to show them. But let's start with step 1. So the thing I want to start with, I want to create a fungible token, and then I want to transfer that fungible token. I want to show you how to mint that fungible token. But before doing that, we will need some accounts to interact with. For example, if you need an account to transfer those tokens, a treasury, for example, and you need someone to receive those tokens. So the first step is creating some of those accounts. So the first thing is, let's create a treasury. Treasury will be responsible for all the fungible tokens created. So we just use the private key library and the method generate ed25519. And I will also create the private key for Alice using the same method. And let's start creating the treasury account. So we can create the treasury by using the create treasury method. And create treasury method, the account creation, create transaction. And I'll set an initial balance for this account of new HBAR 10. We'll give him 10 HBARs, and we are going to set his key as the treasury key dot public key. So we're getting the public key for this specific account. And the last thing we're going to do is executing by using execute and specifying the client, so they're responsible for the payment. Now we can actually, we want to know if this transaction was a success or not. So we're going to get the receipt from this transaction. So create treasury dot get receipt, and you can specify client again. So now you have a receipt. And obviously we just created an account, so we want to get the account ID so we can interact with the treasury, for example. So we can get that by saying, for example, we can call this treasury ID and say create treasury rx receipt dot account ID. And there you have it. So we're going to print after, because I need to do another operation, but we also have to create the Alice's account. So create Alice. You basically do the same thing. So you can copy and paste. I know this is not a good practice in programming, but it's faster. So create Alice, new account, create transaction. We're going to set the same amount of HBAR as initial balance. The difference here will be that the key this time will be Alice key dot public key, and you will be executing with the client again. Create Alice Rx, create Alice, we get the receipt, and then after that, we can get the ID of Alice. So right now we can, for example, print step 1. We just finished the step 1, and we can actually print those. For example, we can say account created, treasury ID, treasury ID, and Alice ID will be Alice ID. So this is step 1. All right, I want to add my credentials for a second without showing you, because we can actually execute the step 1 and see if it works. There we go. So now we can create a new terminal, and we, for example, say node index, and we execute the index. There you go. So you just created 2 accounts, a treasury and an Alice account, and you have 2 accounts ID. If you want to take a look at your transactions, you can also check out on Ashcan. So Ashcan is an explorer. You can find transactions in here. So if you copy, for example, your treasury ID, you can search for it on Ashcan. As you can see, there's a crypto create account. This is the treasury account you just created. You can also do this with all transactions you made or you're making. You can use the Explorer to facilitate the interaction and to better understand what you're doing. And especially if you are getting an error or something, you can check out Ashcan to understand better. So let's go to step 2. So step 1 was creating accounts. And step 2 will be actually creating a fungible token. So the first thing is we're going to create 2 other keys. And you can find these keys in the documentation, as I told you before. These are very important keys, for example, because if you are not setting one of these, for example, I'm creating the supply key. If you're not setting the supply key, then you can't mint the token, meaning that if you, when you create your token, you have to specify an initial supply. You can create 10,000 tokens. But the problem is, if you are not specifying a supply key, you can go over those 10,000 tokens. So this is very important. Not SCDSA, but ED25519. And I'm specifying another key. So I will talk about this after. This will be the web key. So I'm creating this using the generate ED again. And let's create the token. So let's start by creating this function, right? This create token variable with constant token create transaction. By the way, all these functions are automatically imported, but these are the functions we are using right now. So let's specify some parameters. First of all, I'm going to set a token name. How do you want to call your token? What's the name of your token? My name is Francesco. I'm going to use Francescoin, for example. After that, we can specify a token symbol. So I'm calling this French's coin, FC, I think. That is a good symbol. Then token type. And we said this is a fungible token. So you have to import the token type from the object from the library, Hashgraph library, and then specify fungible common. You can also see non-fungible unique in here, but we're doing a fungible token, so fungible common. And after that, as I told you, there's the initial supply. How many tokens do you want to create at first? Let's say 1,000. But right now, I'm going to set a decimal. So this decimal, when I'm setting 2, I'm saying that your initial supply will be 10 in this case, because you're setting 2 decimals. So this will be like this. So right now I want to have 1,000. So if you have 2 as a decimal, you have to add 2. So decimal is useful when you have, when you want to, more decimals means more partitioning of your fungible token. You can also have 0 decimals, and in that case, the least number you can have of your token is 1 or 0, but 1, for example. So I want to have 1,000 fungible tokens, and so I specified. So in this case, it's 100,000, but 2 are decimals. So it's a bit like this, for example, right? You can specify an amount of token that you want to have initially. So make as you like. So make this, if you want to change the name, obviously you can change the name. If you want another initial supply, you can have another initial supply, as you like. So the next parameter is the treasury. So who at first will receive and hold this initial supply. So our treasury is actually the treasury account we created before. So we just specified the treasury ID like this. Then we set a supply type and we import token supply type. You can make this token finite or infinite. So let's say I want this token to be infinite. So we can actually mint an infinite amount of token forever. And now we need to set a supply key. So this will be the supply key we created on line 44 to mint the token in the next steps. After that, I'm gonna tell you what this is, but auto renew account ID. So the auto renew account ID is the one responsible for paying the rent. So as I told you before, you have to renew an account by paying a fee for the rent. So in this case, we can just, instead of creating another account that might be confusing, we already have 2, we can use, for example, the treasury. We can use the treasury account. So the treasury also pays for auto renewal of the token. So the expiration time is around, the max limit of expiration is 9 months, but there's actually an improvement to change that. So you can check our Hedera improvement proposal page if you want to learn more about expiration and rent. So set auto renew period. Now we want to say the period of auto renewal for this token So I just told you that the maximum time to set that you can set is 9 months. So every 9 months, the token will be renewed. The rent fee will be paid every 9 months, and we can specify that period in seconds. So 9 months, I don't know how many seconds, but we can do another at time, a little less. I think it's 9 million seconds, but let's set that to 7 million seconds. Then we are actually setting the wipe key. This is the key I've created before. I want to show the wipe key in another step. So for now, just bear with me and set the wipe key. Then we're going to set the max transaction fee. So you do not want to pay over 30 HBAR for a fee in this case. So it's good practice to set you need to set the max transaction fee to avoid paying too much. And also if you get an error, sometimes it's because you need to increase the max transaction fee. Then we can freeze this transaction using this function called this extension method called freeze with, and by specifying our client. There we have it. So this is our function to create actually create a token. Right now I'm not executing the function, so it's not working. We need to do another line, another 4 lines of code. So first of all, create token signed. We have the create token function, but you have to sign this transaction using the treasury key, because you are specifying the treasury ID as treasury of the token, and to receive those tokens, you need to sign with the treasury key to approve the transaction. And then we can actually execute that. Go, execute using client. So the operator will pay a good amount of money on all these functions. Like, not good, we have low fees, but I mean, the operator will be responsible. You can actually change that by, for example, I want to give you an example here. If you want to change the account responsible for this payment for the token create transaction, you can actually do client.set operator, and for example, say Alice ID and Alice key. In this case, you're paying this transaction using Alice's money. So this is very simple and useful. But let's stick with the operator. So now that we created the token, let's get the receipt of the transaction. Get receipt, client. All right. And now we can get the token ID, the just created token ID, by saying create token Rx. This is our receipt dot token ID. There you have it. You now have your token ID. Let's print the token ID to see if this was successful or not. So this is step 2, and we can say token created with ID, token ID, right? Let's execute. You will see step 1 again running, and step 2. There you go. This is your token ID. You can find this token again on hashscan. So go in here, you search in the search bar for your token ID, and you will see the transaction just happened. So we're talking about this is the fungible token. As you can see, the name is Francescone. FC, the auto renew period 7 million seconds. This is actually 81 days, 26 minutes and 40 seconds. The total supply at thousands, and this, as you can see the decimals in here, and the initial supply. The maximum supply is infinite, and this is the initial supply and total. But when we are going to mint these tokens, the total supply obviously will increase of an amount of your that you wish to mint. Perfect. Let's go to step 3. You can always ask questions, I think, from the event page, or if I'm going too fast or too slow, you can always ask. Matt, I think, is monitoring that. So no worries if you still have to build this, or no worries. I can show you the code more slowly. So we're going to mint a token right now. So create new tokens. As maybe we did an error and we're not happy with, let's say we're not happy with 1,000 token, and we want to mint, I don't know, let's say 5 tokens more, 500, let's say 500. So let's start by creating our mint token. There we go. So token mint transaction. And first of all, we need to say which token do we want to mint? Our token. So we have our token ID available right there. And we have to say what is the amount we want to mint. And in this case, you have to consider again the decimals. So we have 2 of decimals. So if you want to mint 500, you have to add 0, 0 again, because you have a decimal, 2 decimals. And then you're gonna say, you're gonna freeze the transaction. So this transaction can't be modified in any way. And we actually need to sign this transaction. And why is that? That's because we just created a token, and we also introduced the supply key. And that's where we need the supply key. You cannot mint other tokens without this one. So we sign the transaction, and now we can execute it. Like this, mine mint token signed dot execute client. There you go. And again, we want proof that this transaction has been successful. So mint token rx await. These are all asynchronous functions. Oh, sorry. Mint token dx dot get receipt and client. So we can now get, for example, the status of the transaction. You can do this with almost every transaction. It's very useful. You can say mint token rx, you get the receipt, and you get a field called status simply. That's very easy. You can now print the step 3 token minted with status, and you just add the status. Don't forget to convert this to string using the toString method, or you'll get the error message will be a number. So you will get 22, and 22 is the code on the Hedera services for success. But make sure you use the toString method to actually get the message and not the number. So let's execute again the whole script. Step 1 completed, step 2 completed, and step 3 success. Let's see again. As you can see, every time I'm executing this function, I'm creating new accounts, creating a new token, and minting the token on the testnet. So every time I'm creating new entities on the testnet, but that's okay. That's what testnet is for. Let's see the token I've just created on hashscan, so you can actually see the new amount. And there you have it. So this is again the Franchise coin, and the total supply now is 1,500. So we actually minted 500 tokens, and I think they all went to the treasury. So this is working properly. Very good. Let's go to step 4. So we actually want to do the reverse now. We want to, maybe we are wrong. We wanted, I don't know, 1,250 tokens. So instead of minting tokens, we can actually burn them. So burn tokens. All right. And to burn them, you can actually, it's pretty much the same as the mint token transaction. You can actually say burn token equals new token burn transaction. And you have to, again, to set the token ID as our token ID. And then you have to specify an amount you want to burn. So we just minted 500 Franchise coin, and we want to actually delete half of them, let's say, of the newly created token. So instead of having 1,500 tokens, so 1,500, we want 1,250. So we're just going to burn 250 and then add the decimals. So 0, 0. And let's freeze the transaction using the client. And again, let's go to sign this transaction using the supply key again. Execute the transaction. Let's get the receipt from the transaction. And last thing is to get the status. So we actually got the status. So let's print it. Oh, okay. This is auto completion. Okay. Artificial intelligence. Okay. That's very good. So we now have completed the step 4. Let's check if this is actually working correctly. Step 1, again, step 2, step 3, and oh, sorry. As you can see, I just I forgot the toString, and as you can see, this is the number of the success code. So remember to go for toString. Let's do this again. Success. So let's take again the new token number, token created, account ID. So token ID, and we'll see in here on hashscan. There you go. So you can see that the total supply is 1,050 250. So we just burned them. We just burned 250. Very good. Let's go to step 5. So step 5 is actually about associating a token to an account. So we haven't used, I could have used the set max auto association number on account creation, but let's say we want to transfer now some tokens from the treasury to Alice, for example. And I'm gonna associate using the function, but you can actually avoid using the associate function by setting here. When you're creating Alice, you just add one parameter called set max automatic token associations. And you're just gonna use, for example, say 10. And you won't need that the function I'm creating right now, but because I wanna show you in details what this is about, I'm gonna use it. So to Alice's account, let's associate that. Okay, let's start by creating by using the token associate transaction. And first of all, which one is the account we want to associate the token to? Alice. So Alice ID. We specify the Alice ID, and then we set the token IDs we want to specify. And in this case, it's an array, but it is only one key, one token, sorry. So it's the token ID. And we can just freeze the transaction, and we need to take this transaction, associate token, and sign this transaction using Alice's key. So Alice key. Okay. And so now we're going to execute this transaction. We're going to get the receipt from this transaction. Oh, sorry. Get receipt. And we're going to get the status for this transaction. There you go. Associate token to Alice's account. Execute it with status. There you go. Remember the toString extension method. So now we have completed step 5. Let's see if this works properly. Step 1 completed, step 2 completed, step 3 completed, step 4 completed, and step 5 completed. So we just associated the token to Alice's. So now Alice can actually receive those tokens. So let's go to step 6. And we say transfer token to Alice's account. Let's create the transfer token token transfer function by saying new transfer transaction. And in here, you actually have to specify these parameters. So the first thing is add token transfer. So you're saying token transfer. For NFTs, you actually have add NFT transfer. We have fungible token. So we say add token transfer, and we want to specify, first of all, who is the sender. So we're gonna send this token ID, to from the treasury ID, because he's holding all the tokens available, and we would say 10. Now let's say 100, for example, but we have to remember there are decimals, so 1, 2, because of the 2 decimals. So we're sending 100 Francescine to, we had add token transfer, and of this token ID, again, to Alice, by saying Alice ID, and instead of minus, we just take the same amount, so 100 plus the decimals. And then we say we freeze the transaction using freeze with by specifying the client again. Very good. And we can now start executing this function. But in order to execute this function, you actually have to sign this again, obviously using the treasury key this time, because you're transferring from the treasury key to Alice. So await, transfer token sign, treasury key. There you have it. And now we can execute the transaction. So await, transfer token signed dot execute using the client. And let's get the receipt. Not execute, but get receipt using it. Using the client again. And we are going to get the status again. So await, transfer token rx dot status. Awesome. So let's print this result. This is step 6, token transferred with status, transfer token status dot to string. There we go. Let's execute this script again, and then I will show you on HScan what you'll get for the token. Perfect. We transferred the token to Alice. So if we now go to the token ID, we actually have, this takes sometimes also to refresh, to show you the balances. So sometimes you are not seeing the result of your transfer. Sometimes you are, no problem at all. Using the wallet, this is like instant. So let's see, for example, Alice's account. There you go. There you have it right here. So this is the crypto create account. So this is the create account transaction to create Alice's account. And this is the crypto transfer I just made with 100 Francescine minus 100 Francescine to this account. This is the treasury, and we're adding them to Alice's account. As you can see, this is the node, consensus node. In this case, this is the testnet, so it's not the governing council in this case. And as you can see, it's all in here if you want to check. This is easy because you can see if there are any errors. It's very useful. This is a very useful tool. And you obviously, this is for testnet, but you can also use this for mainnet or for PreviewNet if you're developing on the PreviewNet. So you can switch between those. For example, this is for mainnet. This is real-time HBARs going back and forward from an account to another. So let's go to step 7. This is actually the last step of the example, of the live coding session. So the last example is about wiping, and that wipe key I created before. So we are trying to wipe tokens from Alice's account. So what we can actually do with that wipe key is removing the token we just transferred from Treasury to Alice without even Alice's permission. So this is a dangerous key to set. So when you're actually buying tokens, you have to check that. If you want to ensure a trustless way of doing that, I think the wipe key, there are some use cases for the wipe key, but you should be, you should check what you're doing when you're doing it. So avoid doing like setting wipe keys and make bad decisions for your reputation and for your users, for example, your customers. Let's say I want to wipe. For example, we just transferred to Alice 100 franchise coin. Let's remove all the franchise coin. So let's remove all the 100 franchise coin from Alice's account. So to do that, you create the wipe token constant using the token wipe transaction. So first of all, this function needs, first thing it needs, this function is the account ID we want to wipe, so tokens from. So in this case, we want to remove tokens from Alice's account. Then we want to remove which token we want to remove. In this case is the token ID we just created. After that, I'm gonna set an amount. We want to remove 100, but there are 2 decimals. So again, 0 and 0. And at this point, you can freeze the transaction using the client. You have to sign the wipe token, the token wipe transaction using the wipe key we created before. So if you are not creating that key, there's no problem at all. So you can just remove line set 63 and you're good to go. But you have to work based on the solution you're building. So sometimes you will need the wipe key, sometimes you're not. You do not need the wipe key. That's totally up to you. So now we can execute the function, the transaction. So wipe token signed dot execute using the client, and wipe token receipt is await wipe token transaction get receipt. We will get again the status. Oops. This is not needed. And let's print the result. So token wiped with status of the string. Perfect. So the example is actually finished. Let's run this example and let's see if the wiping was successful. Perfect. That is a success. So let's actually see every account as we finished. Let's see every account ID we have. So the first one is the treasury account ID. So these are all the transactions that happened on the treasury that you can see that where the treasury is involved. So as you can see, there is the treasury account creation. There's the token creation. So as you can see, we minted 1,000 initially of Francescoin. Then we minted 500 Francescoin, and the token received all those, as you can see. Then we burned 250 Francescoin, and then we wiped 100 Francescoin from Alice's account. Let's see now Alice's account ID. So Alice's account, there you have it. So as you can see, we created the account right here. I transferred from the treasury to Alice's account 100 Francescoin, and then I wiped 100 Francescoin. So we actually burned from this account the tokens without needing Alice's approval. And the last account ID we're going to see is the token. And as you can see in the token itself, the total supply changed a little. So we started with 1,000 initially, then we minted 500, then we burned 250, then so we had 1,250. Then we transferred from 100 of those to Alice's, and then we wiped those. And by wiping them, we burned them in another account. And by burning them, we're actually reducing the total supply of the token. So right now you have 1,150 Francescoin inside of, as you can see in Hashscan. So I think this wraps up our live coding session. I'm gonna hand over to Matt, I think, again.
Yeah, that's right.
So thank you, everybody.
Cheers, Francesco. That was really good. And obviously what Francesco's walked through there has been essentially a manual sort of walkthrough of how you get started on Hedera with development, how you set up your environment, accessing accounts, how you obviously create an account, and as Francesco said, you can do that manually through wallets or through the portal, depending on which net that you're connecting to. But that example was actually kind of really useful because that kind of shows you the way that you can interact with the SDKs, specifically the JavaScript SDK in that particular setup. And it showed you essentially the ways of being able to connect with each of those kind of concepts manually and executing those transactions manually. When you think about that in terms of building applications and your particular solution that you're looking to create on Hedera, that particular approach may resonate if you wanted that kind of manual control to it as part of the application flow, as part of the business logic. As you start to consider the Web3 of working with distributed applications and sort of pre-compiled logic, as it may be for something like a DEX, for example, obviously you probably wouldn't want to be doing those type of interactions manually in that way. You would have a lot of those encoded within smart contracts to set up the very specific logic that you may want to cater to and have audited and be transparent for people that are using your DApp. So that kind of approach is obviously quite sort of useful for going through and for learning how to connect with the SDK. It may be useful for utilizing with certain applications where it fits the approach that you want to use. But equally, just be mindful that you can then sort of wrap up that type of capability within smart contracts too, as you need to. So hoping you're really connected with that, and that kind of helps you see what it could be like to sort of get yourself set up and get started with Hedera itself. I just want to talk to you quickly in terms of consensus, and then sort of wrap up to show you where we can get sort of further information and what sort of the next steps in the Innovate event will look like for you engaging with Hedera too. So bear with me for a moment, and I'm just going to get my screen sort of shared so I can kind of walk you through that. So bear with me 2 seconds, and I will get this going for you. Just share this screen here too. Okay, that one is screen 2 and share. Okay. So look, what we've gone through there is a high-level intro to Hedera. We've then stepped through some of the different services that we expose. We've talked about use cases. We've gone through a hands-on code example where you've been able to see how you can interact with something like the JavaScript SDK in real time. What I think is kind of quite useful from a development point of view is just to be across kind of what is sitting underneath this. So what actually is happening from a consensus point of view. So with all of these transactions that are going through and being submitted to nodes as you're executing them, as you saw in Francesco's example, you're obviously submitting those transactions to consensus nodes. And part of that is obviously then how that transaction is incorporated into the hash graph, and how we go about sort of consensus as far as that's concerned. So I'm going to talk you through that really quickly so you can kind of understand what that looks like. Okay, so just in terms of consensus full stop, consensus is obviously the mechanism that we go through on a DLT in terms of making sure that the data is synchronized across the DLT. All copies have the same copy of it. If we're thinking about this in terms of blockchains and hash graph, obviously, you know, from a blockchain point of view, that's more of a proof of work type of consensus mechanism. It's heavy load in terms of energy usage. It's highly inefficient in terms of continually pruning off side branches to maintain the integrity of the chain that you've decided is right. And it is something that's difficult to scale compared to hash graph. With the hash graph kind of approach, instead, it's actually the combination of a data structure and a consensus algorithm. So you have the data structure that is the DAG, or the direct cyclic graph, and then obviously the consensus mechanism that's made up of 2 key things. One is the gossip about gossip protocol, which is the means by which that event data is passed really quickly between all the nodes to make sure it's synchronized. And then virtual voting, which is where the actual order of those transactions is determined. So, as I've said before, Hedera currently supports 10,000 transactions per second, and it's partly down to the fact that the consensus algorithm is so efficient and effective that we can actually do that, along with delivering the finality at 3 to 5 seconds. And if none of that kind of makes sense to you, then this kind of visual is often quite useful in terms of being able to visualize that with a blockchain, you're continually chopping off these side branches to try and obviously maintain the integrity of the main trunk that's there, compared to with the hash graph approach, you're actually weaving new events back into this central core all the time. Okay, let's just go through what the gossip protocol looks like, just so that you can get across that from a development point of view. And I'm not going to go super deep on this, but I do just want to give you some visuals around kind of what the protocol looks like and how this works. So if I'm going to sort of explain this, I've got 2 sections that are on the screen at the moment. The one on the left is essentially a group of 8 nodes, and they are named as Alice through to Hank. Those each represent a node on the hashgraph network. And then on the right-hand side, you've got the same 8 nodes, but just represented as vertical lines instead. And it just is represented as such that further down at the bottom of the screen is earlier in time. And as we move forward in time, obviously we're getting later as we get towards the top of the screen. So I'm just going to talk through an example here so you can see what this looks like. If you imagine that a node, in this case, Alice, receives a transaction, could have been one of the ones that was from Francesco's example earlier on. It's received as a message, and then Alice wants to then share that message with somebody else in network. So this is where the gossip concept comes into play. So Alice decides that she's going to tell Dave as part of the gossip about gossip protocol. Now that Alice knows about it, Dave knows about that same data as well, but we're still not at a sort of consensus in terms of everybody being aware of that information. So what happens next is that both Dave and Alice tell another node that doesn't know about the event that information too. So then Bob knows about it, Gina knows about it too. Then what happens is the remaining nodes get filled in too. So now that everybody has a copy of that same message because of the way that the nodes have gossiped with one another as they've talked about that particular event that was sent to Alice initially. So now we have all nodes having the same information. Now, just as a quick side example as well, you can have a scenario obviously where 2 nodes receive 2 different messages, and that's okay. The network is set up to work in that way where it can receive those parallel kind of events in that sort of sense. And so the same process happens here. Bob and Carol received events. They're now telling other nodes about those events too. So we go through the same process again, where the nodes pass that information back and forth to one another so that all of the nodes then eventually have that same copy of information. So now you can see that all the nodes know about all the events. And you can kind of see where it starts looking quite complex on the right there, but that's essentially how that hash graph is built up from a data structure point of view, with the relationships between the events that are sent between nodes. Now, just in terms of the anatomy of each of these messages in here, it is made up of a couple of key bits of information. So obviously there was a cryptographic signature. So when you saw Francesco going through the examples that he did earlier, you would often see there being signatures signing transactions. That's kind of what this represents. There's also a timestamp. And again, you saw that when we were looking at the transactions on the Explorer too, you could see the sort of timestamp as part of the transaction ID. The transactions that were in there, so the specific transactions that we're submitting to the network, and then the hash of the last message you received and the last message you made, and therein enables you to create this data structure on the hash graph that relates essentially the events back and forth across the different nodes. So the nodes are sharing events that are unknown to each other during that gossip protocol. And then basically we reach consensus with virtual voting. So let's have a quick look at that. And let me just shift through to the right slide for you here. Bear with me a second. I'm just going to jump over to this one here. So in terms of that scenario, once the nodes had all had the events shared amongst them, they all had a copy of the data, if you remember from the last sort of slide that we were looking at. What also happens is that when those messages are received by the nodes, they all have a timestamp against those events. And they may be slightly different between nodes, of course, because you're looking at nodes that are distributed globally. So they're going to be slightly different timestamps. So how do you work out what order those transactions should go in when you're thinking about it holistically from the DLT's point of view? So what happens is we actually take all of those timestamps for each of those 3 events that were synchronized across the nodes, and then we order them by those timestamps for each of the nodes. So you can see here, this was all of the timestamps for the red message, the blue one for the green one. Then what we do is we take the median value of that list of values. So the median is really important because it doesn't get affected by, perhaps a rogue transaction that's massively earlier or massively later. By being in the center here, you can immediately omit anything that's on the extremes of the data that's there. So, even in a scenario where you might have a bad actor or something similar that tries to affect consensus, it's not necessarily going to impact by virtue of the median being used in the way that the virtual voting takes place. Once we've got the median for each of those transactions, we can then determine the sequence of those transactions that have gone through. In that way, we can identify the order of the transactions, along with the fact that all of those nodes all have a copy of that same data. So in that way, the nodes can actually go through that approach independently without needing to send votes to one another on a network. And it's partly why that this becomes so efficient and effective for the hash graph algorithm, because you don't need to send those votes over to each node. You don't need the nodes to send a receipt back to one another to say, hey, I've received that vote. Yes, I agree. And go through the consensus in a very kind of network congested form. We can go through it using this approach and ergo have virtual voting. That's a really important part of what makes up the hash graph algorithm. So I'm going to jump out of this presentation for you next briefly. I hope that was kind of a useful insight into how the consensus mechanism works. And now I want to share with you just another slide here. So bear with me a second. I'm just going to jump back into our original Prezzo for you as well. Okay. So bear with me, I'm nearly there. Okay, and I'm going to share my screen. Okay. All right, let me just jump forward on here for you. Okay, so in the workshop today, we've gone through, like I said before, the introduction with Hedera development. We've gone through the core concepts in there in terms of accounts and signatures and some of the ins and outs of that you need to be aware of. We've gone through a tour of the network services, and Francesco has kindly shared some of the use cases that were there too. And then we've gone through explaining the 3 steps to building on the Hedera network. So creating a free development account, choosing your SDK, and setting up your environment. And then you've also had that hands-on coding example from Francesco too. Now, in terms of next steps, we know that with the Ideathon, there's then going to be a period of 48 hours of support that we are going to provide to you. So both Francesco and myself will be available for providing support as you go through building out your solution, and perhaps if you've got questions, and that will be conducted through the virtual event platform that you're viewing this through. So we'll be able to answer any questions on there as well. And there will also be a demo day on September the 1st as well. So there'll be some reviewing of the projects and proof of concepts that you might have put forward on there that we'll provide feedback on too. Obviously, as you know, with the people that have been involved with the session today, the mentors will be myself, and I've identified you're welcome to connect with me through there too, and also Francesco, that's kindly gone through the coding example with you today too. So just in terms of perhaps where to go next and where you can get started and get further help, there is some useful resources here as well. And I'll just kind of give you a quick visual on this so that you can kind of understand where you can go to and what that looks like. So again, bear with me for a moment, and I'm just going to grab this over here. I'm hoping you can see that on screen as well. Francesco, can you just give me a thumbs up? Is that dragged across all right with the browser?
Yeah, I can see that.
Yep, cool. That's all right. I wasn't sure whether it was just a presentation it was sharing then. Okay, so if you kind of want to get to some of the more developer-based information that's going to help you on your journey, you can obviously just come directly to hedera.com. There's a Get Started section over on the right-hand side that will take you through to some information here about how, quick starts for developers, tutorials, open source demos, a link through to our Hedera Discord as well. So for any of you that may not have used that before, Discord's a fairly popular platform in the Web3 and crypto space for communities. So I'd encourage you to jump on Discord, join the Hedera Discord as well. And like I said, there is literally over 14,000 developers in there to help you with your build, with your project that you might be putting together, and to answer questions too. And there's also a mixture in there of both developer evangelists and developer advocates that can contribute to those answers too. So if you do need sort of some help, even beyond the scope of the Ideathon as well, then obviously that's a great place for you to be in and to connect with too. Just in terms of developer support information, going through to the docs is an obvious place, but it's something that I think has really got a lot of value in here too. So there is some walkthroughs similar to what you've seen on the walkthrough with Francesco today, where we talk about things like environment setup, how to create an account, some examples in here, loads of core concepts and walkthroughs of those as well. So that's really useful. And then there are literally then further breakdowns around things like release notes. When you get into the specifics of what's been changing within the ecosystem, that type of thing is really good. And as we've sort of highlighted as well, links through to various SDKs that are supported through here too. So I think that's kind of a great place for you to be able to jump into. So, once you've got a thought around what you want to try and you're then keen to get into implementation, obviously feel free to utilize the approach that Francesco's outlined today. But if you need a bit more support, then the docs are a great place to do that. We've also got links through to articles and videos on these slides, along with obviously a link through to the developer Discord. So I'm going to click through to the next slide. So for those of you that are currently sort of in flight and watching this live, you'll be able to access this whether it's live or afterwards. But ultimately we have a link through to our review form here for today's event. So I'd encourage you to scan that and give us your thoughts and your feedback on the event from today. When you complete that, we will then send you an email automatically straight off the back of you submitting it, that will contain a link to the slides from today. And it will also provide you with links through to joining our developer Discord and also to how to create a testnet account as well. So from there, you're kind of well positioned to be able to move forward with your Hedera development and to be able to be on your way ready for what wonderful things you may want to create as part of the Ideathon event itself. Obviously, like I said, as we sort of move forward, the idea will be for myself and Francesco to continue providing you support as we go through this over the next week or so. And then we look forward to obviously being able to review what it is that you've built and submitted so that we can kind of then provide you with feedback and hopefully see where you go with that as well. I know that there's a few different avenues in terms of things that are going on with the events at the Ideathon. Certainly from a Hedera point of view, we would love to see what you create as you go through this event. And if there are means in which we can support you further, then obviously I've touched on things in today's sessions around obviously us having the HBAR Foundation that looks to support new projects as well. So should you create something from this that you would like to continue with and feel that there's a roadmap for it, I'd obviously be able to encourage you to apply through to the HBAR Foundation for further support too. Other than that, that pretty much wraps up our session for today. And I'd just like to thank you for attending and being part of it. If you do have any questions, we will sort of be monitoring the Q&A section on this too. And obviously we can provide you with some responses on there as need be. I'll just stop sharing that. Okay, Tushar, over to yourself.
Yeah, thank you so much, Matt, and thank you so much, Francisco. I think this was an amazing session. I have already got a lot of DMs requesting me to connect you guys. I think I'll keep bothering you. Meanwhile, with the startup, I think this was really in-depth session. I think a lot of startups are going to benefit from this, and we are looking for these startups to actively collaborate with Hedera and kind of build something valuable to FIS with that.
Yeah, fantastic, and absolutely we support that and look forward to trying to obviously provide that support. And like I said, there's a couple of different channels that we can do with that in terms of the Discord community. Also, obviously directly myself and Francesco will be there through your fantastic platform that you've got for the Innovate event as well. So we're happy to sort of provide support through that too.
Sure. I think with this, we wrap up this session and we look forward for the Ideathon and the next closing session. Thank you so much, Matt. And thank you so much, Francisco, for your time.
You're welcome. Thank you so much for the opportunity. Really value being part of it.
Right.
Thank you, Tushar.
Thank you.
Bye.